to the NEPSI Tech Talk Session 50. We're back here after a brief hiatus, and if you've joined us before, you'll probably notice that I'm not Paul Steciuk. My name is John Steciuk. I'm the Automation and Controls Engineer for Northeast Power Systems. I've been with NEPSI for about 14 years, and I've done everything from building and assembling control panels and building metal enclosed equipment, programming PLCs and HMIs, and protection relays. I haven't done any presentations or tech talks, so this is my first since college. Take it easy on me, please. But I'm glad to be here with you today, and our topic is Modbus basics and configuration. We have a configuration example for you. Before we get into it though, I want to remind you that we do offer PDH credits for your contact time with NEPSI here. If you type your email and your name in the chat box at the end of the session and the code 7654, we'll provide you with a certificate for your PDH credits. I'll give that code out another time throughout the presentation. In case you missed it, it's 7654. And don't forget to ask questions in the chat box at any time. If you have suggestions for future topics, then you can leave them there too. Alright, so I'll give a brief background on Modbus protocol. Not going to dive into it too deep here, but it's an industrial application protocol developed in 1979 by Modicon, which is now Schneider Electric. And it's used to transmit and interpret data between industrial devices or devices in general. There's a few different iterations of the Modbus standard. There's Modbus RTU, which is very widely used in industry. Uses the master-slave model, where the master is controlling the actions of the slave, and the slave is transmitting the data to the master. Uses a serial network with like a twisted pair copper wire, sometimes 2-wire configurations, sometimes 4-wire configurations. Very common. Unlike Modbus ASCII, which is not very widely used at all. It's similar to Modbus RTU, but uses only ASCII characters. In 1999, the Modbus TCP IP standard was introduced. Utilizes IP addressing in a client-server model, which is pretty similar to the master-slave model. The client requests data from the server using function codes or commands, and the server provides the data to the client. And the Modbus TCP IP standard utilizes Ethernet media like RJ45 cable or fiber optic. So that's very convenient with today's devices. Most have provisions for Ethernet connections, and Modbus TCP IP is the fastest growing type of Modbus used, and I think eventually will surpass the Modbus RTU use. So this is just a diagram of the client-server model. We have one client here who is making a request of data from servers. There's multiple servers, and they fulfill the client's requests. So the flow of data is always from the server to the client, and that's kind of the key takeaway from this slide here. And the client requests this data by using the Modbus function codes, which are defined in the standard. And here's a bunch of the function codes. Today we'll be using function codes for reading input status number 2 and forcing single coil function code 5. And we're dealing with just discrete data, so zeros and ones today. But these other function codes, they allow you to read integer data, 16-bit, and that allows you to transmit analog values, analog signals, metered data signals, and all types of like counter data or timer data you can transmit from one device to another. So Modbus function codes are commands from the client telling the server what to do, what data to give it. So that's kind of all I'm going to talk about the standard. We kind of want to get into an application example here. So I have set up with me, got a Micrologix PLC, an SEL 751 relay, and we've got a push button over here, illuminated push button. They're all connected to an Ethernet switch, as well as my laptop connected to the same switch. So the PLC has one input wired to it and one output. The output is the LED, the blue LED push button, and the input is the contact from that push button. So when the push button is engaged, then the contact status will change and let the PLC know. The SEL 751 has no inputs or outputs wired to it. Strictly connected by Ethernet. The only other connection is power. So the point here is that we want to show that we can transmit data without using wired connections aside from the Ethernet cable. So I'm going to get into a little configuration here. Hopefully I don't bore you, but for the SEL 751 configuration, you can fill in some of the general information up at the top if anyone's familiar with SEL Accelerator Quickset. But for this exercise, we're going to focus on the port settings. So the first thing you need to do is make sure that your Ethernet port is enabled. The Ethernet port is port 1 on the 751 relay. So when we highlight port 1, we see that port is enabled, and then we go down to the Ethernet port settings, and this is where you can input your IP address information and subnet, default router, and all that's important for networking. We need to have that right. But we're going to skip down to Modbus protocol configuration. The first setting here, EMOD, enable Modbus sessions. You need to have at least one Modbus session enabled, or else we will have no Modbus. So I have 2 sessions enabled because I've got my laptop hooked up to the SEL 751 as well as the PLC. So next thing we're going to do is put some logic in to the relay. You can do these in the individual logic sections, but I like to do it in graphical logic because I think it gives you a better overall picture of the logic in the relay. I can see all the logic just from this one section, and then after you just compile it and send it to the relay. So what we have here is a latch, and to set the latch we have a push button PB05, which is the push button which is labeled aux1 right here. And we have the output of the latch is T01 LED, which is the target 1 LED on the SEL relay front panel, and that is down here. And then resetting this latch is remote bit 01, RB01. And this remote bit, we're going to be changing the value using the Modbus protocol. We're going to be writing data to the remote bit 01 Modbus register to reset this latch. So you don't want to forget to compile the logic, and you're going to have to send it to the relay. Before you do that, you're going to have to set the IP address in the SEL 751. And you can do that from the front panel display using the keys on the front panel. You could also do it using an SEL serial cable. Those come in very handy. They're pretty quick to make changes, especially small changes to the SEL programming. So then you're going to go to the communication tab in QuickSet, and you're going to select communication parameters, and you can choose network or serial. We're using a network cable, and you type in the IP address of the device, which is 192.168.0.222, and the rest of these settings are default parameters, and we don't need to change anything else. So then you're going to click OK, and you'll make a connection to the relay. And the next thing you need to do is click on Send Active Settings, and that's the highlighted button here with the arrow pointing to the right. Once you click the Send Active Settings button, you're going to get the Settings Group Class Select box where you can choose which settings are sent to the device. You don't have to send the entire SEL logic to the 751 at once. You can just send portions. So we're sending logic, the front panel, and port 1 settings. And then you click OK, and you wait for it to load in, and then your device is set. So pretty simple. We're going to move on to next settings in the Micrologix 1400 PLC, and we're just going to kind of go quickly through. If you're starting a new project, you'll need to select your PLC model. Ours is highlighted here. It's a Micrologix 1400, and you can give it a name. And again, we're focusing on our communication settings here. So we're going to double click on the channel configuration along the left-hand banner on the side. This is RS Logix 500 software from Rockwell. So once you get the channel configuration box open, you're going to see some tabs along the top of the box, and you're going to click on channel 1, which is the Ethernet channel. So it contains all these settings for protocol control down here. You want to make sure that you click on the Modbus TCP enable checkbox, and that's going to give you another tab over here called channel 1 Modbus. So we're going to take a look at that channel 1 Modbus tab. This tab is used to configure this Micrologix as a server. You can specify which data files will hold the data that a client would want to request. So that's what this section here is for. For this exercise, the PLC is going to be a client, so we're not going to make any settings here. So we're going to go back over to the project banner on the side, and we're going to select the ladder logic diagram. We're going to go into the default diagram. We're going to add 4 rungs of logic to get this exercise done. So I'll go through them. On the first rung, rung 0, we have an input to the PLC. This is the contact from the blue push button that's going to reset our SEL LED. And on that same rung, we have a binary coil, which is going to just store the status of that push button contact. For rung 1, we have a system timer, which basically operates about every 1 second, and it's telling this message instruction how often to execute. So I just put this timer in here. It execute about once every second, And these message instructions are what where we specify the Modbus function codes um, so that we can request data from the SCL device. And rung 2 is basically very similar to rung 1. We have that system timer and another message instruction. We're just using a different function code in this other message instruction. You know, whether it be reading or writing, we're doing both in this exercise. So we have 2 message instructions. And then rung 3, we have a binary contact, and we have an output coil. And the output coil is for the LED. It says green LED here. We had to switch it to blue. Didn't realize it would be a problem with the green screen. So my slide's a little bit wrong, but it was kind of funny. Anyway, so yeah, the message instructions are configured to execute the function codes that we need. And if we want to look back on those function codes real quick, function code 2, read input status. Function code 5 is force single coil, and that's what we want to do. We're reading the input status of the SCL's LED here, and then this push button is going to mimic that status. And then we're going to write the status of the push button contact to the remote bit in the SCL so that we can reset the LED on the SCL. Alright, so to set up these message instructions, you need to double click where it says setup screen. I've got them highlighted. And then we need to set the fields for where it says this controller and for target device. And this instruction is going to be to write a single coil, so that's function code 5, and that shows up right under Modbus command. You have to select that. You also have to select the channel, which is Modbus channel 1. The data table address, we have B3:0/0. That's where we're keeping the data that we're going to write. So whatever data is in that binary bit is going to be written when this instruction executes. So down below we have the settings for the target device. You can see the Modbus data address. We need to specify where we're writing to. And this information is found in the instruction manual of the devices. So SCL has a very thorough instruction manual. They have a complete Modbus register map, and I was able to find that the register address for the remote bit 1 coil is 28. You also need to make a routing instruction file in the Micrologix software to allow this instruction to execute. And we specify the IP address of the target device in the bottom. And this message instruction is also a good location to do some troubleshooting. If you're online with the Micrologix 1400, then you can check here for error codes if you're having trouble with your communications. So we'll go on to the next message instruction, and it's very similar. Like I said, channel 1, integral Modbus TCP. We're going to change the command to command 2, and that's to read input status. So the data table address in this case is going to be where the data resides after we read it. So we're reading the status of the LED, and that is going to be put into the location B3:0/1. And the Modbus address for this data is 6. And let's see, we have all the other information is the same as the last. So this is going to be used to to read the status of the T01 LED. So our logic is done and our settings are made in the message instructions. We have to compile the logic and we're going to send it to the PLC. But first we need to set the IP address in the PLC, and there's a few different ways we can do that. I prefer setting it from the LED screen, LCD screen. It's just the way I like to do it. But you can also use RS Links, which is a software provided by Rockwell. Or you can set it for boot P, which the devices on the network broadcast their MAC ID, and based on that you can assign an IP address to a particular MAC ID, and that's another way you can set the IP address. Or with DHCP automatically. So once we have our IP address set, we're going to go to on the top banner, comms, system comms, and we're going to browse the Ethernet driver and just select our device, which is 192.168.0.220, and we're going to click download, and you're going to go through a couple of other pop-up windows that are going to ask you to confirm a few things, and you need to stop the PLC if it's in run mode and put it back in run mode once it's loaded. It'll ask you if you want to go online, but at that point you've got your PLC settings done, and we've got our SEL settings done. So we're going to go and see if we got this working here. Okay, so the plan was when we push this push button here, we should see an LED come up here. The PLC should read that data from the Modbus registers just through this one cable, and it's going to mimic the status on this blue push button. So let's see if that works. And it looks like it does. And likewise, we've got we're going to write data from this PLC to the SEL751 to reset. So we're taking this contact from this push button to an input in the PLC, sending that via Modbus to change the status of remote bit 01, and that works good. So I know it's not really too fancy, but if you think about it, there's a lot of different applications you can use for this, and you can do this all without wiring a whole lot of inputs and outputs. And also, you know, we're just using bits right now, but if, as I mentioned earlier, there's integer data you can use to get data from another relay and put a set point in some other relay on the other side of the plant, or use it for, in our case, for metal enclosed capacitor and harmonic filter banks. We could use like reactive power data for switching stages on and off. We could display all this kind of data on HMI screens for easy visibility for the end user, and we've done that in the past, and it works pretty good. So there's all kinds of applications you can use this for, and I did want to go over one additional item here. We have I use ModScan to do some testing for my communications. I just wanted to show you guys what that looks like. It's pretty basic looking, but what it does, it allows you to read data from your device on your computer. So right now I have this connected to this is connected to the SEL751, and I'm looking at the LED status, and you can see I've got the LED on right now because it's showing a 1. When I push the button here, we're reading a 0 now. And I just think this is a useful tool in troubleshooting and in setup of communications, and I just wanted to share that with you. It's one of the things I use. So that's about the end of my exercise here. If you guys have any questions for me, I'd be happy to leave the question screen up and take them. And I'll give you a few minutes to do that. If you're looking for PDH credits, the code is 7654. You can leave that in the chat window along with your email and name, and we'll get you your PDH certificate. So I'm going to put the question screen up, and I'll wait a few minutes to see if anyone has any questions. If not, then it's been nice talking to you, and I hope you have a nice rest of the day. Alright guys, I don't really see any questions in the chat, but I appreciate the feedback from you all, and being my first Tech Talk session, I think it went okay, and I hope to be able to do some more of these sessions for you guys, probably on a monthly basis. So keep an eye out. I'll be posting the link again, and we'll come up with a good topic for next time. Thank you.